Students, I welcome you once again to my third session on software engineering. So, let me briefly discuss about the topics which were covered in session 2. We saw what is software problem and we have discussed one use case and where we understood that software built by the student is entirely different from the industrial strength software with respect to quality, usability, then portability, etc. Then we saw what are the important software characteristics that play a major role in the entire software engineering process. And characteristics were cost, schedule, and quality. Cost with respect to uh, productivity, like lines of code being written, or it can be with respect to effort you put. Schedule means the delivery time taken or cycle time taken for industry or for business to deliver the software, time taken to deliver the software. That speaks about schedule. And quality is nothing but it is a factor through which you measure the productivity of the product. Okay, and we understood that there are multiple dimensions through which we can measure the quality. Next, we saw factors affecting the quality. It was mainly reliability and maintainability. Reliability was like providing a software which is free from failure. Okay, and maintainability is something like we have to extend our service in spite of delivering the software to the customer, because customer expect some changes here and there, so we have to provide the service. Hence our software has to get maintained even after our software is being delivered to the customer. Next, we saw quality and productivity. So you understood that both productivity and quality are the basic drivers for the project, and we also saw that quality can be measured through different criteria. So let me continue with my topics that I'm going to cover in my session 3. So I would be discussing the other software characteristics like change, rework, scale, and consistency. Then we will summarize the entire topics which were covered in Unit 1, particularly in software problem, which is a part of Unit 1. Okay, so the topics that were covered in session 1, session 2, and session 3. Then again, I have kept an assessment question just to evaluate your understanding, students. Okay, so we will follow the same approach. I will be discussing the answer. You can think the answer and try to map with the discussed answer. So let me start with the topic other characteristics, change. So students, what do you mean by change? So they usually say change is the only thing that is constant in business. Okay, because here and when customer keeps on changing their requirement, that is why change remains constant. Change is always there in your project. It is who has to get adapted to the environment. We cannot say no to the changes being asked or being asked requested by the customer. ಸೊ ಚೇಂಜ್ ಯಾವತ್ತೂ ಇರುತ್ತೆ ನಿಮ್ಮ ಬಿಸ್ನೆಸ್ಸಲ್ಲಿ. ಓಕೆ, ಸೊ ನಾವು ಅದಕ್ಕೆ ಅಡ್ಯಾಪ್ಟ್ ಹಾಕೋಬೇಕಾಗತ್ತೆ, ಬಿಕಾಸ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ದೇರ್ ಫೀಚರ್ ಕೀಪ್ಸ್ ಆನ್ ಮಾಡಿಫೈಡ್ ಬೈ ದ ಕಸ್ಟಮರ್. ದಟ್ ಈಸ್ ವೈ ವಿ ಹ್ಯಾವ್ ಟು ಚೇಂಜ್ ಅವರ್ ಕೋಡ್. ದೆನ್ ಹೇಳಿರೋ ಹಾಗೆ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಚೇಂಜ್ ಇವನ್ ವೆನ್ ದ ಪ್ರಾಜೆಕ್ಟ್ ಇಸ್ ಇನ್ ಪ್ರೋಗ್ರೆಸ್. ಸೊ ನಿಮ್ಮ ಪ್ರಾಜೆಕ್ಟ್ ರನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ ತಕ್ಷಣ ದೇರ್ ಇಸ್ ನೋ ಹಾರ್ಡ್ ಆ್ಯಂಡ್ ಫ್ಯಾಕ್ಟ್ ಟು ದಟ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಚೇಂಜ್ ಆಗಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು, ಆಯಿತಾ. ಸೊ ದ್ಯಾಟ್ಸ್ ವೈ ಯಾವಾಗ ಕಸ್ಟಮರಿಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೀಚರ್ ಬೇಕು ಅಂತ ಅನ್ಸುತ್ತೋ ದೇ ಮೇ ಕಮ್ ಟು ದ ಇಂಡಸ್ಟ್ರಿ ಆ್ಯಂಡ್ ದೇ ಮೇ ಆಸ್ಕ್ ಫಾರ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಚೇಂಜ್. ದೆನ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಡೂ, ವಿ ಹ್ಯಾವ್ ಟು ಚೇಂಜ್ ಇನ್ ದ ಕೋಡ್. ಸಮ್ ಮಾಡಿಫಿಕೇಶನ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಡನ್ ಇನ್ ಸ್ಪೈಟ್ ಆಫ್ ಯೋರ್ ಪ್ರಾಜೆಕ್ಟ್ is in progress. Third one, it is said that in a project, up to 40% of development effort may go just in implementing the changes. Okay, so out of 100% effort ಅಲ್ಲಿ ನಿಮ್ಮದು 40% ಡೆವಲಪ್ಮೆಂಟ್ ಎಫರ್ಟ್ ಜಸ್ಟ್ ಚೇಂಜಸ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಲಿಕ್ಕೋಸ್ಕರನೇ ಸ್ಪೆಂಡ್ ಮಾಡ್ತೀರಾ ನೀವು. ಫೈನ್. ಆ್ಯಂಡ್ ದೆನ್ ಇಟ್ ಈಸ್ ಸೆಡ್ ದಟ್ ದ ಸಾಫ್ಟ್ವೇರ್ ವಿಚ್ ಈಸ್ ಬೀನ್ ಡೆವಲಪ್ಡ್ ಮಸ್ಟ್ ಅಕಮಡೇಟ್ ಚೇಂಜ್. ಸೊ ನೀವು ಮಾಡುವಂಥ ಸಾಫ್ಟ್ವೇರ್ ಮುಂದೆ ಚೇಂಜಸ್ ಇನ್ ಕೇಸ್ ಬಂದರೆ ಅದನ್ನು ಅಕಾಮಡೇಟ್ ಮಾಡೋ ಥರ ಇರಬೇಕು. ಸೊ ಫ್ರಮ್ ದ ಡಯಾಗ್ರಾಮ್ ವಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ್ಯಾಟ್ ಯೂಸರ್ needs will be given to the industry. We start implementing the needs, requirements, fine. Then software is being developed, and again you can see a back arrow which says satisfies. ಅಂದರೆ ನೀವು ಡೆವಲಪ್ ಮಾಡಿರುವಂಥ ಸಾಫ್ಟ್ವೇರು ಯೂಸರ್ ನೀಡ್ ಜೊತೆ ಮ್ಯಾಪ್ ಆಗಬೇಕು. ಯೂಸರ್ ನೀಡ್ ಹ್ಯಾಸ್ ಟು ಗೆಟ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್. ಹಿಯರ್ ಆ್ಯಂಡ್ ವೆನ್ ದ ಯೂಸರ್ ನೀಡ್ ಮೇ change, ಆಯ್ತಾ? So all the changes has to be incorporated properly, and each and every change has to be satisfied with the user needs. So this is about change. Next characteristic would be rework. So what do you understand by rework? So rework, it is said that people in industry, they find rework as the biggest problem in most of the large and complex project. Why? Because see, rework ಅಂದ್ರೆ it is an extra effort that you have to put. ಹೌದಲ್ವಾ? ಸೊ ವರ್ಕ್ ಮಾಡ್ತಾ ಇರುವಾಗ ಏನಾದರೂ ಚೇಂಜಸ್ ಬಂದ ತಕ್ಷಣ ಯು ಹ್ಯಾವ್ ಟು ಸ್ಟಾರ್ಟ್ ರೀವರ್ಕಿಂಗ್. ಸೊ ಆಲ್ರೆಡಿ ಸ್ಪೆಂಟ್ ಎಫರ್ಟ್ ಅದು ಏನಾಗುತ್ತೆ, ಐ ಕ್ಯಾನಾಟ್ ಸೇ ಇಟ್ ಮೇ ಗೋ ವೇಸ್ಟ್, ಬಟ್ ಯು ಹ್ಯಾವ್ ಟು put an extra effort in order to incorporate the changes being requested by the customer. So people find it as a biggest problem. Then to avoid rework ಏನು ಮಾಡಬೇಕಾಗತ್ತೆ, we have to specify the requirements, functionalities, interfaces and constraints well in advance before the development. Okay, so rework ಅನ್ನು ನಾವು ಆದಷ್ಟು ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂದರೆ you have to be very clear, or you have to clearly specify the requirements, functionality, interfaces well in advance before the development phase begins. ಹಾಗೆ ಮಾಡೋದ್ರಿಂದ ನಿಮಗೆ ಕ್ಲಾರಿಟಿ ಇರುತ್ತೆ, ಆಯಿತಾ? ಕಸ್ಟಮರ್ ಏನು ಕೇಳ್ತಾ ಇದ್ದಾನೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು. ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಇಲ್ದೇ ನೀವು ಡೆವಲಪ್ಮೆಂಟ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿಬಿಟ್ರೆ ದೇರ್ ಇಸ್ ಅ ಚಾನ್ಸ್ ದ್ಯಾಟ್ ಯುವರ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಮೇ ಚೇಂಜ್, ರೈಟ್? ಸೊ ಹಾಗಾಗಿ ದೆನ್ ವೈ ರೀವರ್ಕ್? ಯಾಕೆ ರೀವರ್ಕ್ ಮಾಡಬೇಕಾಗತ್ತೆ? ಬಿಕಾಸ್ requirement is not understood completely and clearly by the people before the development, so that may leads to rework. So ಡೆವಲಪ್ ಮಾಡುವಂಥ ಟೀಮ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ನ ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳದೆ ಹೋದರೆ ಆವಾಗ ಏನಾಗುತ್ತೆ, ರೀವರ್ಕ್ ಆಗೋ ಸಾಧ್ಯತೆ ಹೆಚ್ಚಿರುತ್ತೆ. ಫೈನ್, ದಟ್ ಈಸ್ ವೈ ಇಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ಅಸ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಕಂಪ್ಲೀಟ್ಲಿ ಆ್ಯಂಡ್ ಕ್ಲಿಯರ್ಲಿ. ಹಾಗೆ ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ರೀವರ್ಕ್ ಬರೋ ಸಾಧ್ಯತೆಗಳು ಕಡಿಮೆ ಹೇಳ್ಬೋದು. ಬಟ್ ಕಸ್ಟಮರ್ ಸೈಡ್ ಫ್ಯೂಚರಲ್ಲಿ ಫೀಚರ್ ಎನ್ಹಾನ್ಸ್ಮೆಂಟ್ ಬಂದರೆ ದೆನ್ ವಿ ಕೆನಾಟ್ ಅವಾಯ್ಡ್ ಇಟ್, ವಿ ಹ್ಯಾವ್ ಟು rework. That's what fourth point say. Client needs additional requirements during development. So in this case, you cannot avoid rework. Additional requirements bandaga, we have to rework. Then in large and complex system, clients often request for change of requirements. Okay, so bigger project idaga, it is a normal tendency that change of request ಬರ್ತಾ ಇರುತ್ತೆ ಕಸ್ಟಮರ್ ಕಡೆಯಿಂದ. ಫೈನ್, ಸೊ ದಟ್ ಈಸ್ ವೈ ವಿ ಹ್ಯಾವ್ ಟು ಗೆಟ್ ಅಡಾಪ್ಟ್ ಅವರ್ ಸೆಲ್ಫ್ to that kind of environment. So that was about rework. Third characteristics, we will see what is scale. So scale is usually measured in terms of small, medium, large and very large, right? So methods for solving small problems, they do not often scale up for larger problems. ಅಂದ್ರೆ ನೀವು ಯಾವ ಮೆಥಡ್ನ ಸ್ಮಾಲ್ ಪ್ರಾಬ್ಲಮ್ನಿಗೆ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಿರೋ that method may not suit in order to solve the larger problem. Fine, so that's why we say do not often scale up ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಯಾವ ಸ್ಟ್ರಾಟಜಿ ನೀವು ಫಾಲೋ ಮಾಡ್ತಾ ಇರ್ತೀರಾ ಒಂದು ಸ್ಮಾಲ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ, ಸೊ ಸೇಮ್ ಸ್ಟ್ರಾಟಜಿ ಮೇ ನಾಟ್ ವರ್ಕ್ ಫಾರ್ ದ ಲಾರ್ಜರ್ ಪ್ರಾಬ್ಲಮ್. ಸಾಫ್ಟ್ವೇರ್ ಇಂಜಿನಿಯರಿಂಗ್ ಮೆಥಡ್ಸ್ ಮಸ್ಟ್ ಬಿ ಸ್ಕೇಲೆಬಲ್. ಸೊ ಒನ್ ಆಫ್ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫೀಚರ್ ಅಂದರೆ ಏನು, ಇನ್ ಸಾಫ್ಟ್ವೇರ್ ಇಂಜಿನಿಯರಿಂಗ್ ವಾಟ್ ಎವರ್ ಮೆಥಡ್ಸ್ ಯು ಫಾಲೋ ದೇ ಶುಡ್ ಬಿ ಸ್ಕೇಲೆಬಲ್. ಓಕೆ, ಸೊ ಪ್ರೊವಿಷನ್ ಇಟ್ಟಿರ್ಬೇಕು ನಾವು ಸ್ಕೇಲೆಬಲ್ಗೋಸ್ಕರ. ಯಾಕೆಂದರೆ ಹೇಳಿರೋ ಹಾಗೆ ಚೇಂಜಸ್ ಬಂದಾಗ ಇಫ್ ದ ಚೇಂಜಸ್ ಆರ್ ಆಲ್ರೆಡಿ ಇಂಪ್ಲಿಮೆಂಟೆಡ್ ಇನ್ ದ ಪ್ರೀವಿಯಸ್ ಫೇಸ್ ಬಟ್ ಪ್ರಾಬ್ಲಮ್ ಈ ಸಮ್ ವಾಟ್ ಬಿಗರ್ ಅಂತ ಅನ್ಸಾಗ ಆವಾಗ ವಿ ಮೇ ಫಾಲೋ ದ ಸೇಮ್ ಮೆಥಡ್ ಫ್ರಾಮ್ ಸ್ಮಾಲ್ ಟು ಲಾರ್ಜರ್. ಅಂದರೆ ವಿ ಸೇ ದ್ಯಾಟ್ ಅವರ್ ಸ್ಟ್ರಾಟಜಿ ಮಸ್ಟ್ ಬಿ ಏಬಲ್ ಟು ಸ್ಕೇಲೆಬಲ್. ಸ್ಟ್ರಾಟಜಿ ಅಂದರೆ ವಾಟ್ ಮೆಥಡ್ ವಿ ಆರ್ ಫಾಲೋವಿಂಗ್ ಅಲ್ವಾ, ಸೊ ದ್ಯಾಟ್ ಮಸ್ಟ್ ಬಿ ಸ್ಕೇಲೆಬಲ್ ಫ್ರಾಮ್ ಸ್ಮಾಲ್ ಟು ಲಾರ್ಜ್. ದೆನ್ ವಿ ವಿಲ್ ಸಿ ಟೂ ಡೈಮೆನ್ಷನ್ಸ್ ಇನ್ ಅ ಪ್ರಾಜೆಕ್ಟ್. ಸೊ ಪ್ರಾಜೆಕ್ಟಲ್ಲಿ ಯೂಶುವಲಿ ಟೂ ಡೈಮೆನ್ಷನ್ಸ್ ಇರುತ್ತೆ. ಒಂದು ಇಂಜಿನಿಯರಿಂಗ್ ಮೆಥಡ್ಸ್ ವಿಚ್ ಸ್ಪೀಕ್ಸ್ ಆಫ್ ಟೆಕ್ನಿಕಲ್ ಎಸ್ಪೆಕ್ಟ್, ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಒನ್ ವುಡ್ ಬಿ ಪ್ರಾಜೆಕ್ಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್. fine. So who will be controlling project management? Project manager. It is somewhat about administration, ಆಯ್ತಾ? So engineering methods and project management are the two dimensions in a project. Then for small project, both the dimensions, engineering as well as project management, can be done informally on the health way. And we need not follow systematic approach, ಆಯ್ತಾ? Because since the project is small, engineering methods and project management can be done informally, whereas that is not the case for the larger project. You have to follow both engineering methods and project management in a systematic manner, in a formalized way. Fine. So that's why we say both dimensions have to be formalized in a larger project. Fine. So this is about scale. So we'll see like one picture which justifies or which supports to my previous point. Okay, so let us say development method along the x-axis and project management along the y-axis. Then as the picture say, for smaller project, your development method and project management are informal. ಹೌದಾ? But when the project change from small project to larger complex project, then the methods what you follow, development methods ಆಗಿರಲಿ ಅಥವಾ project management ಆಗಿರಲಿ, has to be formalized. Okay, so that is why scale factor ತುಂಬಾ ಮ್ಯಾಟರ್ ಆಗುತ್ತೆ. You should be able to scale from informal method to formal method. Fine, because uh, scale is an important factor that the software engineering needs. So I hope this diagram makes sense for you. Okay, so let us see some more extra points or some more example with respect to scale. So let me deal with one example. So students, try to understand this: counting the number of people in a room versus taking a census. So I hope you know what is census. Hoda? So both come under counting problems. Yes or no? So both are related to counting. But methods used in the first case will not be useful for census. That is what scale tells you. Hoda? So methods what you use in the first case may not be useful for the census. For large scale counting problem, you must use different techniques and models. Yes. So if the problem is larger, then you must use different techniques and models to cope up. And in that case, management will play a critical role. Okay, because we have to scale up and we have to get adapted to that, right? So management role also is critical there. Fine. So this is about, so I hope this example is clear. So counting the number of people in a room is easier, right? It is a small problem, whereas taking a census, counting the number of head count geographically is a bigger task, is a huge task, and you need different strategy over there. You cannot say that what strategy you have followed in counting the number of people in a room, the same strategy I will follow in census. No, it is completely different, even though both speaks of counting the problem. So this is what you mean by scale. Okay, so method in development ಆಗಿರಲಿ ಅಥವಾ project management ಆಗಿರಲಿ with respect to software, both has to scale when the project, when the size of the project changes from small to large. Okay, so this was about scale example. Here is one more example which is given in a tabular form, which speaks of size of the software in terms of lines of code, then specific software and the languages used. So what you can understand here is, see how the size of the code changes with respect to software, even though all software helps you in solving the same like problem. Okay, so GCC, again it is a compiler. Fine, it's a product. Perl, again it's a product, right? See the size: 980, 320. OpenSSL 200. You are using the same language, NCC ಆಗಿರಲಿ ಅಥವಾ C++, Perl. Okay, so using the language for this particular software, see the size of the code different ಆಗಿದೆ ಅಲ್ವಾ? So what does it say? So Scale will be measured in terms of small, medium, big, large, or very large. And your software engineering process, what you follow, must be scalable. Software in the software ಲೈನ್ ಆಫ್ ಕೋಡ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ನಿಮ್ಮ ಸಾಫ್ಟ್ವೇರ್ ಇಂಜಿನಿಯರಿಂಗ್ ಪ್ರೊಸೆಸ್ ಕೂಡ ಸ್ಕೇಲ್ ಅಪ್ ಆಗಬೇಕು ಅದಕ್ಕೆ. ಸೊ ಐ ಹೋಪ್ ದಿಸ್ example makes sense. So let us continue with the other characteristics that speaks about consistency and repeatability. So what do you mean by consistency? So consistency ಅಂದ್ರೆ ಯೂನಿಫಾರ್ಮಿಟಿ, ಅಂದರೆ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಒಂದೇ ರೀತಿ ಪರ್ಫಾರ್ಮ್ ಮಾಡೋದಕ್ಕೆ ಕನ್ಸಿಸ್ಟೆನ್ಸಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸಮ್ಟೈಮ್ಸ್ ಏನಾಗುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಗ್ರೂಪ್ ಆಫ್ ಪೀಪಲ್ ಇನ್ ಅ ಟೀಮ್ ವಿಲ್ ಡೆಲಿವರ್ good software sometime but may not be able to deliver good software in the second chance. ಹೌದಾ? What may be the reason? Consistency ಇರಲ್ಲ ಅವ್ರ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಅಲ್ಲಿ. Okay, that's why. So it has become a challenge in software engineering how to ensure that success can be repeated. So success ನ ರಿಪೀಟ್ ಮಾಡೋದೇ ದೊಡ್ಡ ಚಾಲೆಂಜ್ ಆಗಿಬಿಟ್ಟಿದೆ ಸಾಫ್ಟ್ವೇರ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲಿ. ಫೈನ್. Then consistently producing high quality software with high productivity is again a bigger challenge. Okay, so consistently ನಿಮಗೆ high quality software ಬೇಕು with high productivity ಬೇಕು ಅಂದರೆ task is not that easy. Fine, you have to follow some strategy which will help you in giving the consistent performance. A software organization wants to deliver high quality and productivity consistently and repetitively across the project. So project length may vary from project to project. One project 2 months run ಆಗ್ಬೋದು, ಇನ್ನೊಂದು project 6 months run ಆಗ್ಬೋದು. Okay, but it is the goal of every software organization to delivering high quality and productivity consistent ಆಗಿ ಹಾಗೆ repetitively. ಅಂದರೆ success every time it has to get repeated across the project. They try for that. Okay, so that should be the basic goal of all the software organization. Then frameworks like International Organization for Standardization and Capability Maturity Model focus on this aspect. So there are different bodies like ISO, CMM who work in measuring the performance of the software project. Okay, so they have given certain criteria. Based on that criteria, we measure what is the performance, whether it is consistent, whether it has got repeated. Fine. So that is the duty which will be performed by frameworks like International Organization for Standardization. In short, we say it as ISO, and Capability Maturity Model. In short, we say it as a CMM. So that's it, student. So that is almost towards the end of my session 3. Topics covered were other characteristics. Fine. So scale and change ಹೇಳೋದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. Then we saw this thing, consistency and repeatability. I hope those characteristics were clear. Fine. So let me briefly summarize what all we have understood from the unit 1. We understood what is software problem, right? So the problem domain for software engineering is industrial strength software. Okay, so ಯಾವಾಗಲೂ ನಾನು ಸಾಫ್ಟ್ವೇರ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲಿ ಸಾಫ್ಟ್ವೇರ್ ಅಂದ ತಕ್ಷಣ ಇಟ್ ಈಸ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಸ್ಟ್ರೆಂತ್ ಸಾಫ್ಟ್ವೇರ್ ಸ್ಟೂಡೆಂಟ್. Then cost, schedule and quality are the basic driving forces for systematically developing industrial strength software. So cost, schedule and quality, they play a major role in developing the industrial strength software. Beside developing software, the goal is to achieve high quality and productivity. So just not only giving the software within the time frame, goal ಏನಾಗಿರಬೇಕು, you have to give the high quality and productivity software within the time limit. Then only you will be success. Okay, so that's what we have understood. Then productivity can be measured as lines of code delivered per person month. So since entire chapter speaks about quality, productivity, that is why productivity play a major role. ತುಂಬಾ ಸ್ಟ್ರೆಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. Yes, so that's why ಪ್ರೊಡಕ್ಟಿವಿಟಿನ ನೀವು ಹೇಗೆ ಮೆಜರ್ ಮಾಡ್ತೀರಾ? ಇಟ್ ಈಸ್ ಮೆಜರ್ಡ್ ಥ್ರೂ ಲೈನ್ಸ್ ಆಫ್ ಕೋಡ್ ವಿಚ್ ಗೆಟ್ಸ್ ಡೆಲಿವರ್ಡ್ per person month. Andre one person in a month, how much lines of code he writes. Okay, so that's why it is a ratio of output to input resources anta karvi. Output is nothing but lines of code and input is nothing but effort being put by a person in a month. Then we saw what are the different methods which we must follow in order to accommodate the changes and also to handle larger problems. So methods used andre your methods, whatever methods you follow, whatever strategy you follow, it must be scalable. Okay, and it must accommodate changes. So in the beginning, in the first session, we saw software engineering is an engineering approach wherein we follow different strategies, different systematic strategies, andre well defined methods agirli, well defined procedures, ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ನೋಡಿದ್ವಿ ಅಲ್ವಾ. ಸೊ ವೆಲ್ ಡಿಫೈನ್ಡ್ ಮೆಥಡ್ಸ್, ಯಾವುದೇ ಮೆಥಡ್ ಆಗಿರಲಿ, ಇಟ್ ಮಸ್ಟ್ ಅಕಾಮಡೇಟ್ ಚೇಂಜಸ್ ಆ್ಯಂಡ್ ಮಸ್ಟ್ ಬಿ ಏಬಲ್ ಟು ಹ್ಯಾಂಡಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸೊ ಸ್ಕೇಲ್ ಆ್ಯಂಡ್ ಕನ್ಸಿಸ್ಟೆನ್ಸಿ, ಸೊ ದೀಸ್ ಟು ಯು ಹ್ಯಾವ್ ಟು ಕೀಪ್ ಇನ್ ಮೈಂಡ್, ಫೈನ್, ವಿಚ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಇನ್ ಹ್ಯಾಂಡ್ಲಿಂಗ್ ದ ಲಾರ್ಜರ್ ಪ್ರಾಬ್ಲಮ್. ಸೊ ದ್ಯಾಟ್ಸ್ ಇಟ್. ಸೊ ಐ ಹೋಪ್ all the topics of unit 1, particularly with respect to software problem, is clear. So before I wind up with my third session, let me just briefly discuss about the MCQs being put over here, just to evaluate your understanding again. So first question, who manages the effect of change throughout the software process? So software process ಅಲ್ಲಿ ಆಗುವಂಥ changes ಯಾರ ಕಂಟ್ರೋಲಲ್ಲಿ ಇರುತ್ತೆ? Is it a software project tracking and control department who takes care of it, or is it under software configuration management, or does it come under measurement, or does it come under technical review? So students, let me stress some points. Let me discuss some points on software configuration management. So software configuration management is a separate department in the software development life cycle whose main job is to build the code or build the project. Build andre compilation. See, ನಾವು ಕೋಡ್ ಚೇಂಜಸ್ ಮಾಡಿದಾಗ ಸಿ ಪ್ರೋಗ್ರಾಮಲ್ಲಿ ಆಗಿರಲಿ, ಯೂಶುವಲಿ ಇನ್ ಆರ್ಡರ್ ಟು ಹ್ಯಾವ್ ದ ಇಫೆಕ್ಟ್ ಆಫ್ ಚೇಂಜ್ ಇನ್ ಅವರ್ ಕೋಡ್ in the final output ಅಲ್ಲಿ we have to do the compilation. If you don't compile it, those changes won't get reflected, right? So there is a separate department in the software development engineering process ಅಲ್ಲಿ whose job is to compile the whole project again and again. So that department we call it as a software configuration management. So now we will discuss the answer. So who will manage the effect of change throughout the software process? So yes, the solution would be B. It is software configuration management. I hope what you have understood what exactly you mean by software configuration management. So separate department who takes care of changes throughout the software process. Next question would be, which of the activities listed below is not a part of software engineering process? So let us see the list. Software development, software dependence, software validation, and software specification. So which activity you find is not a part of software engineering process? So we saw what is software development. We have discussed a little bit on software validation. We saw what is software specification, right? Only thing which is not been discussed here is software dependence, right? So hence solution would be B. Software dependence activity is not a part of software engineering process. So next question would be, line of code of the product comes under which type of measure? So the options were indirect measure, direct measure, coding, none of the above. And hence you can see the solution is B. So line of code of the product comes under direct measure. So we knew this. That's why I did not discuss much on this. Okay. So let's move on to the fourth question. Reliability deals with providing failure-free software service, meets the need of the customer, solve the problem, or all of the above? So again, it is a straightforward question. So reliability definition prakara, providing failure-free software service. So hence solution is A. So let's see the fifth question. Compilers, editors, software come under which type of software? Okay, so compilers, editors, they are the product software. What do you think they come under which type of software? Options are, is it a system software, or is it an application software, or is it a scientific software, or none of the above? So yes, it is a system software, because compilers and editors, we knew that they are the system oriented software, and solution A would be the right answer. Sixth question, give the real world factors affecting the maintenance cost. So what would be the real world factors? As and when technology advances, it becomes costly to maintain old software. So technology advance ಆಗ್ತಾ ಹೋದಾಗ ನಮಗೆ ಓಲ್ಡ್ ಸಾಫ್ಟ್ವೇರ್ನ ಮೇಂಟೈನ್ ಮಾಡೋದು ಕಾಸ್ಟ್ಲಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Fine. So that may again affect the maintenance cost. The standard age of any software is considered up to 10 to 15 years. Okay, so ಒಂದು standard age of any software would be considered as 10 to 15 years ಅಂತ ಇದ್ದಾಗ ನಮಗೆ ಆಫ್ಟರ್ 15 ಇಯರ್ಸ್ ಮೇಂಟೆನೆನ್ಸ್ ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ. ಅಗೇನ್ ಇಟ್ ಮೇ ಎಫೆಕ್ಟ್ ದ ಮೇಂಟೆನೆನ್ಸ್ ಕಾಸ್ಟ್. ಮೋಸ್ಟ್ ಮೇಂಟೆನೆನ್ಸ್ ಇಂಜಿನಿಯರ್ಸ್ ಆರ್ ನ್ಯೂಬಿ and use trial and error method to rectify the problem. So ಮೇಂಟೆನೆನ್ಸ್ ಇಂಜಿನಿಯರ್ಸ್ ಫ್ರೆಷರ್ ಇದ್ದಾಗ ಅಥವಾ ಹೊಸದಾಗಿ ಬಂದಾಗ ಜಾಯ್ನ್ ಆದಾಗ ದೇ ಯೂಶ್ವಲಿ ಯೂಸ್ ಟ್ರಯಲ್ ಆ್ಯಂಡ್ ಎರರ್ ಮೆಥಡ್ ಟು ರೆಕ್ಟಿಫೈ ದ ಪ್ರಾಬ್ಲಮ್. And fourth option given is all mentioned above. So what do you think? So answer is been already like justified along with my explanation, right? So all three stands good here. So that's why solution would be D. So technology advance ಆಗ್ತಾ ಹೋದಾಗ it becomes costly to maintain old software, and standard age 10 to 15 years ಇದ್ದಾಗ ಮೇಂಟೆನೆನ್ಸ್ ಕಾಸ್ಟ್ ಅದಕ್ಕೂ ಜಾಸ್ತಿ ಮೇಂಟೆನೆನ್ಸ್ ಮಾಡಬೇಕಾಗತ್ತೆ ಅಂದರೆ again it would cost you more. Then maintenance engineers, when they are fresher, they use trial and error method, so that may again increase the cost of the maintenance process. That's why solution is D, all mentioned above. So let us see the seventh question. Mention any two indirect measures of product. So quality, is it a efficiency, or is it accuracy, or both A and B? So several times I have told you it's quality and efficiency through which which helps you in measuring the productivity of the product. Okay, so it is having an indirect criteria, because quality and efficiency both cannot be measured through a direct criteria or through a specific criteria. So both has its own different criteria which changes from project to project. That's why solution would be D, quality and efficiency. So next question would be, what is the most common measure for correctness? So options given are defects per 1000 lines of code, or is it error per 1000 lines of code, or is it dollar per 1000 lines of code, or pages of documentation per 1000 lines of code. So which is the best suited option here? So correctness na measure ಮಾಡಲಿಕ್ಕೆ ನಿಮಗೆ ಯಾವ feature, like what factor you consider? It is defect, right? So defects per 1000 lines of code, that is what productivity tells you. What you do, you have to correct the code. Correction ಯಾವಾಗ ಬರುತ್ತೆ? When you have a defect in the code. Okay, so defect would be the most common measure for correctness. Ninth question would be, the rules of writing if then else, case which, while until, and for control flow statements are called. Options are comments, functions, line length and wrapping, or control structure. So we have already learned C programming. So reason why I had kept this question is, we know we have studied lines of code. So there was something what I spoke about coding, right? So when I say coding, you can use any of the languages. So what do you think? If then else, case which, such statements come under which category? Is it a comment, function, line length and wrapping, or control structure? Yes, use your common sense. It is control structure, right? So solution is D. Then 10th question, each time the number of defects when it gets reduced, what happens to the quality of the software? Does the quality of the software increases, or it remains constant, or does it get decreases, or none of the above? So what do you think? What is the most appropriate answer? Your quality of the software increases, right? So the solution would be A. So each time the number of defects, if it gets reduced, the quality of the software increases. So with this 10 question, 10 MCQ question, I come to the end of my third session. So references are same. I have referred a textbook called Concise Introduction to Software Engineering by Pankaj Jalote, then lecturer notes on software engineering by Francis Xavier Engineering College, one more notes written by Dr. R. Mall, and last but not the least, software engineering lecturer notes by Mukesh, Mr. Mukesh. Okay, so once again, by thanking all the author, I would like to end up my third session. So I hope my session was good. Fine. Thank you.